Hello, welcome. Question 11A, WASSCE 2025 Further Mathematics Ghanaian student. So, given that f of x is x divided by x squared minus 1, where x cannot be equal to 1 or negative 1, and g of x as x divided by x plus 2, where x cannot be negative 2, and x belong to the set of real numbers, you have to find the inverse of the g function, then the g inverse of g of f of x. All right, then the largest domain of the inverse of g of x, of inverse of g of f of x. All right, I think that will be how you call that. So let's see. Let's start with the first one. We know that here we can translate that into f of x equals to x divided by x squared minus 1. Then the g of x will also be translated to be equals to x over x plus what? 2. So if we are looking for the inverse, let's say we are looking for the first one, inverse of this, we can say that we let the g of x to be equals to the dependent variable, which is what? Y. That make your y to be equals to x divided by x plus 2. Why do we do that? We do that in order to find the inverse. And how do we do that? Here we are going to interchange the position of both x and y. So let's say interchanging x for what? Y. Let's see. Meaning I should be having the dependent variable now become what? X equals to y divided by what? Y plus what? 2. Then we now solve and make y the subject. So we cross multiply. That make y to be equals to x times this will be xy, x times this will be 2 what? 2x. But it is the x we want to make the y we want to make the subject. So let's bring this in here to have y minus xy equals what? 2x. If you factorize y out, you'll be left with 1 minus x equals to 2x, but your y will now be equals to 2x divided by this coefficient 1 minus what? X. So here we can only conclude and say, therefore, the g prime of x, right, which is the inverse, will now be equals to 2x over 1 minus what? X, where your x cannot be equals to what value? 1, right? X cannot be 1. If x is 1, then it becomes what? Undefined. So for the first part of the question, finding the inverse of what? The g function, we have that to be 2x over 1 minus what? X. Now, the next question is to find the g prime of f of what? X, right? So we are going to say that if you pick f of x, it means f is pregnant with x. But now it's going to be g prime is going to be pregnant with the f function, which we have as this. So let's keep this in mind as we clean here and continue. Okay, so let's go to question number 2, which is asking for this of f of x. This is the same as g prime of x, and the x is f of x. Meaning, if you check here, the g prime of x is pregnant with x value. So we are having x. Now, it is now pregnant with f of x. Meaning, everywhere I see x, I introduce the f of x. So this is now going to be g prime of f of x equals to, what do I have? 2 as a constant multiplying x over x squared minus 1. This represents the f of x divided by 1 minus the f of x, which is now going to be x over x squared minus 1. This still intact. Alright, let's ignore here and focus on this. Remember, these two can only multiply the numerator. Can I move it in this line because of space? I should be having 2x divided by x squared minus 1, all divided by, you can see that this is going to be divided by 1. X squared minus 1 become the LCM. So when 1 go here, it goes here, this amount, multiplied by this x squared minus 1, minus this cancelling itself, remaining 1 times that. So I should be having only x squared minus 1, or let me change the position and bring the x first, minus 1, all divided by x squared minus what? 1. Remember, this is a long division, dividing the two fractions. So let's see, we can now bring in here to become, this implies that your g prime of f of x is now going to be 2x divided by x squared minus 1. If we are going to change this to multiplication right away, right? This become multiplication. Okay, let me still maintain the negative. Let me still maintain the division and see. So that become x squared minus this over x squared. I'm only trying to conserve the space, but let's go on and the length of the video. So this become 2x divided by x squared minus 1. Now this become multiplication, flip over x squared minus 1 divided by x squared minus x minus 1. We can see here, we'll cancel that. So your g prime of f of x will be nothing but 2x in the numerator divided by x squared minus x minus 1. I think the second question is asking us just to find this. So this becomes the final answer for the second part of the question. Then the third part is asking for the largest domain, the values of x that can satisfy this equation. Now, what are the pool of numbers that we can replace x with that will make this to be what? Satisfied. That is the domain you're looking for. So let's clean here and work with that also. So we can say that this is going to be Roman number 3. Number 2, number 3. So we can say that the largest domain of g prime of x is going to be, okay, let's still maintain. I always want to conserve space, but I have no option. This is going to be 2x divided by x squared minus x minus 1. Now, for this, we need to check for the, what do you call it, the undefined values of x, or the values of x for which this is undefined. That's the first thing we check. If we can check that, all values we can put in the numerator will always make it valid. So let's see, for undefined, we can only set the denominator to be equal to what? 0. If we set that to be equal to 0, then we can say that the values we get, where x will be equal to, we can eliminate that values from the set of numbers that will be the domain. Alright, I'm tempted to just put this in a calculator because it can't be factorized, because this is -1 and -1. So we can use the quadratic formula to arrive at the answer, or just put this. Okay, let's see. We can have our a, the first value here, the b as -1, the c as what? -1. So it means x will be equals to, do I have to put the formula? The space I'm conserving. So let's say -1 plus or minus the root of the discriminant. The discriminant is b squared, so that -1 squared minus 4ac, right? Divided by 2a, and the a is 1. So I'm just going to go ahead and have my x equals to +1, +1, positive, so 5 will be in here, 2. So let's put all together to be 1 plus or minus the root of 5 divided by what? 2. We're going to have two values in here. Those two values cannot be part of the domain, right? So I can say that therefore the domain is going to be a set of x such that x belonging to the set of real numbers with exception. Will I say except? Okay, let me put equals to this as 1 plus or minus the root of 5 over what? 2. We can also state as the set of x such that x belonging to real numbers except x equals to this, or comma x is not equals to it. Means all values, all real numbers. X can be all real numbers with exception of what? These very two answers you're going to get. Alright, thanks for watching. Like, share, comment, subscribe, and come back for more.